Many people believe that you don't need to know any math to be a computer programmer. While that may be partially true, understanding some essential math concepts can make programming much more accessible and help you unlock the secrets of the digital world. Now let's explore the 10 math concepts that every programmer should be familiar with. 1. Boolean Algebra. Boolean algebra is a fundamental concept in programming. It deals with binary variables that can have only two values, true or false. We use three operators to work with Boolean values, and, or, and not. Let's imagine these as tools for making decisions. For example, if you want to know if someone is both rich and handsome to get a girl, Boolean variables can help you decide. If both conditions are met, he gets a girl. If not, he may have other options. You can represent this logic using if statements, Venn diagrams, or truth tables. 2. Numeral systems. Computers use base 2 numeral systems, unlike humans who use base 10 systems. In base 2, numbers are represented using only two symbols, 0 and 1. This is called binary. Understanding binary helps us work with other numeral systems like base 16 and base 64, which are essential in programming, especially for encoding and representing data. 3. Floating point numbers. Floating point numbers are how computers represent real numbers. They are not always precise, which can lead to tiny errors in calculations. These numbers use scientific notation to handle large and small values efficiently. Knowing the limitations of floating point numbers is crucial for avoiding these errors in your code. So here you can see a positive float in the print method. And here you can see a negative float. 4. Logarithmic functions. Logarithms help us understand how some natural phenomena work. Think of a logarithm as a way to measure how many times you need to cut a log to reach a specific length. In programming, logarithmic functions are used in algorithms like binary search. These functions play a vital role in various applications, from algorithms to scientific research. 5. Set theory. The set theory deals with collections of unique values. In programming, this concept is used extensively, especially in databases where tables are sets of unique rows. Joining sets, finding intersections, unions, and differences are common operations in this context. So understanding set theory is important for working with databases and data manipulation. 6. Combinatorics. Combinatorics is all about counting things and combinations. Whether you're developing algorithms for news apps or designing globally distributed databases, combinatorics helps you calculate all possible combinations or permutations efficiently. It's a valuable skill in programming. 7. Graph theory. Graph theory involves nodes connected by edges. This concept is used to model relationships and connections. Understanding graph theory is vital for solving problems like network routing and optimizing various scenarios. 8. Complexity theory, big O notation. Complexity theory helps you analyze the efficiency of algorithms. Big O notation is a tool for expressing the time and memory complexity of algorithms. It helps you choose the most efficient solution for your programming tasks, a valuable skill for interviews and writing efficient code. 9. Statistics. Statistics is essential for various fields of programming, especially artificial intelligence and machine learning. Understanding basic statistical concepts like mean, median, mode, and standard deviation is what makes you best at making predictions. So it's the foundation for making predictions and decisions in data-driven applications. 10. Linear algebra. Linear algebra is essential in computer graphics, deep neural networks, and many other areas of programming. It involves scalars, vectors, and matrices to represent and manipulate data. If you want to work with 3D graphics, cryptography, and machine learning, then linear algebra come into play. You need to master linear algebra to tackle these. Here is a recommendation for you. Figma is a fantastic tool for developers. The majority of UI designers use Figma to transfer web and mobile app designs. Given this tendency, front-end web or mobile developers need to familiarize themselves with Figma to work with UI designers. If you don't know how to work with Figma design, you will fall behind in modern coding projects, leading to unproductive website building, and you will have to learn it in the future, so sign up now and play around with it before your colleagues or boss blame you. To wrap up this video, mathematics is a powerful tool in the world of programming, and these 10 concepts are just the beginning. They can help you develop more efficient code, solve complex problems, and unveil the magic behind the digital world. These math concepts will make you a better programmer, and you'll be well equipped to conquer a wide range of challenges in the ever-evolving field of technology. Thanks for watching, and make sure to subscribe to this channel to stay updated.